Problem 6. Integral of sine cubed of x cosine to the 8th power of x dx. And part of the issue is just deciding which identity to use. So let's take a look. We have sine squared of x equaling 1 minus cosine squared of x. If you did that, you would borrow 2 of the sine squareds, turn into 1 minus cosine squared, and you have a sine of x being left over at the back, which could end up being a du. If we chose cosine squared of x to equal 1 minus sine squared of x, you would end up getting an even number of cosines left over at the back. So we could keep doing cosine squared, cosine squared, and get a whole bunch of sines. But there'd be no cosine left at the back for use substitution. We could also let sine squared of x be 1 minus cosine of 2x, and you'd have a sine of x left over. But in this case, you'd have an integral that has a cosine of 2x in it and a sine of just 1x in it, and you've got a mismatch of the argument of the trig functions. Likewise, for cosine squared, you have an issue. So the one at the beginning, sine squared of x is equal to 1 minus cosine squared of x, is where we are going to begin this problem. And continuing on, again, we're going to let sine squared of x equal 1 minus cosine squared of x. So we take one of those sines, put it at the back, saving it for du, and we have now at the beginning only sine squared of x, cosine to the 8th power of x, and we're going to trade that sine squared of x into 1 minus cosine squared of x. So hopefully you see where we're going. We're going to have all cosines in the beginning, which they'll be the u would be cosine of x, and your du is going to be sine of x dx. So we get the integral of 1 minus cosine squared of x times cosine to the 8th power of x. So we're going to separate this into two separate integrals and get the integral of cosine to the 8th power of x sine of x dx minus cosine to the 10th power of x sine of x dx. Again, we're going to let u be cosine of x, and du is going to be negative sine of x dx. So we have to kind of balance that out because we don't have a negative sine of x in there. So we'll put a negative on the outside, put a negative sine of x on the inside, and get negative integral of cosine to the 8th power of x times the negative sine of x dx. And again, with the other one, we have a double negative because we're going to put a negative in and we already have one. So we get plus cosine to the 10th power of x sine of x dx. Do our u substitution, and we get the negative of an integral of u to the 8th du plus integral of u to the 10th du, and use our power rule, negative u to the 9th over 9 plus u to the 11th over 11. Back subbing, get an answer of negative cosine to the 9th power of x over 9 plus cosine to the 11th power of x over 11 plus c.